This is the Honors Geometry Semester Exam Review for Unit 1, Topic 1. The first question asks us to write the three undefined terms in geometry. There are three words in geometry that are not formally defined. That is a point, a line, and a plane. In geometry, a point has no dimension. So this is one of our undefined terms. Even though we represent a point with a dot, the point has no length, width, or thickness. And a point is usually named with a capital letter, and in a coordinate plane, it is named by an ordered pair. The next one is a line, and in geometry, a line has no thickness, but its length extends in one dimension and goes on forever in both directions. Unless otherwise stated, a line is drawn as a straight line with two arrowheads indicating that the line extends without end in both directions. A line is named by a single lowercase letter or by any 2 points on the line. The third one is a plane. And in geometry, a plane has no thickness but extends indefinitely in all directions. Planes are usually represented by a shape that looks like a parallelogram. Even though the diagram of a plane has edges, you must remember that it actually has no boundaries. A plane is named by a single letter, like plane M, or by three non-collinear points. Question number 2 asks us to construct the angle bisector of angle A below. Well, with this, I don't actually have a compass, so I'll walk you through the construction, but it will not be accurate. You want to start with finding your vertex. In this case, this is the point right here, point A. You can take any measurement on your compass and you're going to make an arc. So that arc's going to go through both sides of your angle, and then taking another measurement, or the same, it doesn't really matter, you're going to go from each end point. So let's say I start with my first one, the one right here. I'm going to take whatever distance I have on my compass, and I'm going to make an arc. I'm going to take that same distance and go from my other point right here and make an arc. So the only thing that's got to have the same distance is when you make these two arcs. What it's going to do though is they're going to intersect, and you can connect a line that goes through the vertex and the intersecting point, and that will be your angle bisector. Question number 3 asks us to construct a right angle at point B below. So we need to create a perpendicular line that goes through point B. The only construction we know that makes a right angle is the perpendicular bisector. So basically we need to bisect this line through point B, and the only way to do that is to first extend the line in the other direction. Then you're going to take any length that you want with your compass, and from point B as your starting point, you're going to take that same length on both sides. What this is going to do is create point B as your center point, and these 2 points are equidistant from point B. Then from each of these new points, you're going to take your compass and make sure you have a measurement that's more than halfway. So it's got to be a length that ends somewhere over here. And from this original point right here, we're going to make an arc of that length above and below. We're going to take the same length and now go from our other point, and we're going to make that arc, which is going to go up here and down here. Somehow that's going to give us 2 intersecting points, and if you did it right and connect them, it's going to go through point B as well, and it's going to create your right angle. So you're constructing a right angle at point B. Question 4 says a road construction crew wishes to construct a new road parallel to the current road and passing through the town of Herkimer marked by point H below. Construct the location of the road. So here's our current road, here's our point. And basically we're trying to construct a parallel line through that point. I'm going to construct it using the rhombus method because I personally think that's easier. But you absolutely can do the construction by angle copying method. And if you want more help on how to remember how to do this, mathopenref.com is a great website that has videos on how to do all of the constructions. So you can search in that website, find constructing a parallel through a point by the angle copy method or by the rhombus method if this isn't clear. Because I do apologize, without having a compass, this is not going to be accurate. So with my method, the first thing I'm going to do is I'm going to start at point H and I'm going to pick a length that is longer than the distance to this road. So I'm going to pick a length that where my compass from here to maybe about here. And I'm going to construct it, and what I'm going to get is some kind of loop. And I want to make sure that my construction, my loop, goes all the way around and as far up to at least pass possibly where that point should be. So you want to have it go somewhere up here. If you need to do a full circle, by all means do a full circle. From this point of intersection, you are going to take the same compass length and measure an arc in this direction. So taking that same compass length, I'm going to have something, possibly around here. Then from this point, I'm going to do it again, and I'm going to have it intersect with my original arc. And that's going to get me a second point at which I can then construct my parallel line through that point. And there's my new road, which is parallel to my current road. Again, if this doesn't make sense, please go to mathopenref and search for constructing a parallel through a point. And there's two methods. There's the rhombus method, which is what I just did, and there's the angle copy method, which you can absolutely look up if that was what you are more comfortable with. Questions 5, 6, and 7. 5, 6, and 7 are very similar questions dealing with perpendicular bisectors, angle bisectors, and parallel lines. Question 5 says the perpendicular bisector of line segment AB is constructed. What is true about every point on that perpendicular bisector? Well, according to the definition of a perpendicular bisector, what we know is that every point on that perpendicular bisector is equidistant, meaning the same length from points A and B. Question 6 says the angle bisector of angle CDE is constructed. What is true about every point on the angle bisector? Well, similarly to the perpendicular bisector, we know that every point on the angle bisector is equidistant, meaning that same length, that same distance from the sides of the angle CDE. And remember that this is referring to the shortest distance, which is always the perpendicular to that side length. Question 7 says a line is constructed parallel to a given line. What is true about the corresponding points on the line? Well, we know that two parallel lines never intersect, otherwise they're not parallel. So what we know is that each corresponding pair of points must be the same distance from each other. And that concludes Unit 1, Topic 1 of the Honors Geometry Semester Exam Review.